Hey, this is Leach with Simpson Math, and in this video, we are continuing to look at how to factor using the AC method by looking at some interesting cases to give you a few more tools in your tool belt. Now, if you haven't watched my previous videos, especially the one where I introduce AC method, what are you doing here? Go back and check those out. You can be lost on this video. Now, if you're ready to go, let's get started by factoring 4x squared minus 12x plus 9. All right, so working through the 6 steps that are printed above me, it's already in order. We got a GCF, it's good. Sorry, we actually don't have a GCF, it's just one. And then notice this time, the factor pair is all the way at the bottom, but this time our factor pair is -6 and -6. It's the same number. That's because 36 is a perfect square. So one, we have this opportunity, but what's special about this one is when this happens and it's the same number, let's follow along through these steps. So what's the GCF of the first two? 2x. What's the GCF of the second two? A -3. So make sure we bring down that negative. And then I have a 2x minus 3. And I can pull that out and I leave inside a 2x minus 3. No, I didn't just repeat myself. Well, I guess technically I did, but they are the same binomial. It's 2x minus 3 times 2x minus 3. So I can write this as 2x minus 3 squared. So what's special about this is this 4x squared minus 12x plus 9 is what's called a perfect squared trinomial. If you think back to previous few videos where I talked about what if you have 2x minus 3, a binomial, and you need to square it, what do you need to do? You need to write it twice and FOIL. So notice this is a binomial squared produces a perfect square trinomial, meaning literally I could square root it and I would end up with square root of 2x minus 3 squared or just 2x minus 3. This is a perfect square. It's a perfect square trinomial. So anytime you end up with the same binomial, for it to be fully factored, do write it as a squared binomial. Now, we were tasked to find the roots of them. So I only need to do it once, right? So if I did 2x minus 3 equals 0, and then again 2x minus 3 equals 0, I'm obviously going to end up with x equals 3/2 twice when I add the 3 divided by 2. So I don't need to do it twice. I can just do it the one time. Now, if that's not mathematical enough for you, some of you might be like, but that's weird, we're just doing it once. You could think about square rooting both sides, and then the square root and the square cancel each other out, and you just have 2x minus 3, just one of them, which is what I had over here anyway. So it's just one, so I only have to do it once, and I get my x equals 3/2. All right, looking at this example, before you freak out, yeah, there's an x to the 4th. Heck, there's also even an x cubed. You might be like thinking to yourself, Mr. Leach, we haven't even talked. What are you doing? Trust me, you got this. Okay, so step 1, they're already in order. It's just now a 4, a 3, and then a 2, still in order. Step 2, pull out the GCF. The GCF in terms of numbers, nope, 8, 10, 3, nothing in common. But what about the exponent? I'm sorry, what about the variables? So I have 4x's here, 3x's here, and 2x's here. So they all have at least 2x's. So I can just factor 2x's out of each of those and pull out my x squared right here. So my GCF is just x squared. And then at this point, it's just a regular old factoring problem. So 8 and 3 is 24. Factor pair is 4 and 6, which adds to 10. 10 splits to that 4 and 6. And we end up with treat this as just any old regular GCF. It just follows you like a little lost puppy. It's just a little bit bigger. Maybe it's a little lost dog. And we have x squared, then times that 2x plus 1, and 4x plus 3. So that's what's special, a little special trick on that one. All right, looking at this one, you can probably spot right off the bat what's different about this. We have negative GCFs. Remember, if the leading coefficient is negative, just like we've been experiencing throughout in these middle steps, then that means that the GCF is negative. So looking at the numbers, I have a 3, 8, 3, no variables in common. So, but I do have a GCF of -1. So that's what I've been saying. Make sure that when you factor out the GCF, it says including that -1. Make sure you factor out that -1. So I factor out that -1 here, and basically when you do that, the signs change. So it goes from negative, negative, positive to positive, positive, negative. And that's kind of an easy way to double check that. So then AC is this 1 times -3 is -9. And then what multiplies to be -9 and adds to be a +8. That's 1 and 9. And then replace this and we get our -1, +9. Students who don't factor out this negative, they do get the -9, but they'll end up with the wrong signs here with the negatives, and then things tend to go awkward with some of these steps in the middle here if you don't factor out the negative. That negative is crucial for it to be pulled out. So, but it just follows you all the way down, and you get -3x minus 1 and x plus 3. All right, this one, let's find the roots of f of x is -5x cubed plus 10x squared plus 75x. So put them in order, good to go. Now GCF is -5x, right? So they all have a 5, they're all multiples of 5, and they'll have at least one x. This starts with a cube, so that's kind of a tip-off, but that's going to happen. So they all have that x, so we pull out a -5x, and left inside is x squared minus 2x minus 15. So that's really the only part that's new so far, is we have not just a negative, not just a number, not just a variable, but all three. But once you pull it out, once you pull that GCF out, it's just the same old, same old. What multiplies to be -15 and adds to be -2, 3 and -5, split it up, move on down, and then this -5x just joins the GCF on the outside. It's that straightforward. But since we were finding the roots, so let's set each of these to be equal to 0. So what do I do with this? Some students freak out. They're like, but it doesn't look the same. It's not a binomial. But is -5x one of our factors? Yes. So set it equal to 0. It has an x in there. Can't throw it away. So set it equal to 0. Here we can divide by -5, and we end up with x equals 0. Then add the 3 to that, subtract the 3 from that, add the 5 to this, and we end up with -3, 0, and 5. Now, admittedly, you could have, from either of these steps, divided by -5. So if you didn't want that -5 there anymore, you could have divided out the -5, but you could not have gotten rid of the x. So you could have divided by -5, and it would have looked like this. But if you did that, you would have just ended up with x equaling 0 from this step. So that's another option on how to deal with that -5. Because we are solving with roots, it was not just a little expression by itself. All right, so let's move on to this one. All that I really wanted to point out with this is this step right here. Some students get freaked out in this GCF step when we're factored by grouping. So let me just start at this line. So we have a, what does 20x squared and -4x have in common? Well, 4x. So divide that out. And I'm left with 5x minus 1. Remember, -4x divided by 4x would be a -1. Now what about this over here? Well, what does 5x and -1 have in common? What is their GCF? Well, the GCF of 5x and -1 is just 1, right? There's nothing that's in common. So pull it out, air quote, pull it out, write it here. So it's a +1, right? I'm just going to basically just stick parentheses around it, and it's not doing anything. So that freaks some students out. They're like, I don't have anything to factor out. You do, just factor out that 1, which I know fundamentally doesn't change it, but the way in which we're doing this is necessary, so that way in this step, I then, my 3 follows down, I then have my 5x minus 1, factor that out as another GCF, and then what is left inside? Well, I have a 4x and a +1. So that plus is just a +1 that goes there. That's why this is important. The only time you'd ever actually have to deal with this issue here is, one, if you always write the one that's closest, write the factor pair B that's closest to 0 first. The only time you ever will have to deal with this is if your last term is either a 1 or a -1. That's the only time that would happen. If you sometimes do it the other way around, then you might see it more often than I would. So that's how that works. So that's just that little weird trick. And then last one that we'll talk about in this video is this one. As you can see, it looks a little bit different. Let's go through the process. So what is 6 times GCF is 1, all the same. So 6 times -5 is -30. So let's work through our list here. What multiplies by what can I multiply to get -30 and add to be -17? Well, in class I'll have students work and try this one, and they're certain that -2 and -15 work, right? -2 plus -15 is -17, but that does not add up to be that does not add up. That does not multiply to be -30. -2 times -15 is a positive 30, not negative. So do you see why that does not work? And I have this explained down here. So I would have to have one has to be negative, or one would have to be positive in order for me to get -30, and I can't. If I do that, I get negative or positive 13. So I'm not going to get a -17 from this list here. So this trinomial is prime. There are no factored pairs with integer values that will multiply together to get this. It's not going to happen. Let me restate. There are no binomials with integers. So ax plus b times cx plus d. So if a, b, c, and d, none of those, if those are integers, there's nothing that exists that when multiplied back out would produce this. So we deem this a prime trinomial. That happens. There's actually a whole bunch of them, an infinite number of them out there. So you might also come across those that just can't be factored. Not the end of the world, just can't be factored. All right, in our next video, I'm going to wrap up our AC method with a discussion about a special case that some of you might have been like, but Mr. Leach, why are you doing a little bit extra work? Trust me, I have a plan. So join me in the next video, and I will make your I'll make this AC method be a little bit easier in some cases. So join me in the next video.